everyone. I've gotten the same questions a few times over the past couple days, which I normally means I did not explain something clearly enough in the lecture videos. So I wanted to just do a quick summary of one of the issues this week so that you can follow my train of thought and kind of see where I'm coming from with this week's discussion board when it comes to the part where you determine if you can reject your null hypothesis or if you have to or if you fail to reject the null hypothesis, and in turning that z-score into something that you can tell statistical significance. So that's what this little mini video is going to be addressing. If you totally and completely understand this process perfectly, then great. Don't worry about it. If not, then you are in the right spot. So as a reminder, what we are doing with statistical significance is we are saying, is it likely that the result that I got actually means something, that it's valid, or is there a chance that I arrived at this result just based on coincidence, right? And so if you reject your null hypothesis, you get to reject your null hypothesis when you've achieved statistical significance. Because remember, your null hypothesis is the statement of no effect. To use the example that I give in this week's discussion board, my null hypothesis would be that there is no relationship between the stress reduction seminar and how much stress the students actually have. Taking that stress reduction seminar had no impact on overall levels of stress for the students, right? That would be my null hypothesis. So in order to be able to reject that, my results need to show I have a strong enough pattern here to say, I don't think that that's true, that there's no effect. I can reject that idea, or I shouldn't be using cause and effect language. I can reject that idea that there is no relationship there between the reduction seminar and the actual stress levels. I can reject the idea. I can reject the null hypothesis. So the way that this actually works, if you will go back to your textbook on page 112 and 117, it introduces this idea of taking a z-score and turning it into statistical significance. Because you have your z-score curve, and you're basically saying, if my z-score has fallen above this point or below this point, then I'm going to assume that's an extreme enough result that it's not due to a coincidence. So what are these numbers? If you are, and these are numbers you just need to memorize. Remember, in behavioral scientists, we usually work with a p-value of 0.05, which translates to there is a less than 5% likelihood that my results are based on coincidence, are based on chance. For a statistical significance level of p less than 0.05, if you are doing a one-tailed test, a directional hypothesis, your cutoff for p less than 0.05, your z-score needs to be either greater than 1.64 or less than negative 1.64. So it needs to be in one of those tails, okay? If you're doing a two-tailed test, your z-score needs to be greater than 1.96 or less than negative 1.96 to do p less than 0.05. So let me apply that to the example that I gave in this week's discussion board, right? I said I'm setting up a pretend scenario where 100 students took a stress reduction seminar and then took a stress test to see if the stress test actually made any sort of difference compared to the general student population, right? This was my setup. So what I would do is say, okay, if I want a 0.05 significance level and I'm going to do a two-tailed test, because maybe the stress reduction seminar stressed them out more because maybe they're stressed about being stressed, right? So I'm not going to propose a direction. I'm just going to see, did the stress reduction seminar have any impact on the students? So if I'm going to do a two-tailed test, I'm going to say, okay, my cutoff for my z-score is 1.96. My z needs to be at least 1.96, either more than it or less than negative 1.96, in order to say it's statistically significant. If you look at the example I did on the Chapter 5 discussion where I worked it out, you'll see that the z-score that I came up with in my pretend example was negative 8.88. So what does that mean? If I had set my cutoff as p less than 0.05, which translates to needing a z-score of less than negative, more negative than negative 1.96. So it needs to be, z-score curve, and it needs to be over here, negative 1.96. And mine is negative 8.88 all the way floating around over here. I have achieved statistical significance. I have a z-score that would indicate that I have a p-value of less than 0.05, meaning that there is a less than 5% chance that these results were arrived at based on a coincidence, based on chance alone, which means that I could confidently say that there was a statistically significant relationship between students taking the stress reduction seminar and having a lower score on their stress test than the general student population. So that's an example of how you would translate your z-score into whether or not it was statistically significant and work with what the real world language would be. So I would be rejecting my null hypothesis. I'm rejecting the idea that there was no relationship there because I found a relationship. So I get to reject my null hypothesis. If I didn't find a relationship, say my z-score had been negative point or negative 1.1, and I need at least negative 1.96. So say it was negative 1.1. I have failed to reject my null hypothesis. I don't have the math to support the idea that I could say I reject the idea that there's no relationship there. So I failed to reject it. Okay. Hopefully that makes more sense. If there are still questions, please let me know, but hopefully that helped to clarify that some. And just as a reminder, page 112 and 117 in your textbook is where it really starts to dive into this idea.